Okay, so this is where we were as the video ended. We were doing the objectives between C and F. I extended my mirror while the last video was uploading. So you'll see that the rays from the top, the reflected rays cross down here. So this is where my head is. And the rays from the bottom, the orange ones, the reflected rays cross up here. So this is where the feet of my image is. And so what is this image? Well, it's inverted again, and so it's also real. So image is real, inverted, this time larger, and beyond C. So if you look at what's happened then, originally it was beyond C, the object was beyond C, and the image was between C and F and tiny. If you can imagine then, we moved the object in and the image moved out. As the image moved out, it got larger. So when they met at C, they were exactly the same height. Now we keep moving the object in, and the image keeps moving out and keeps getting larger, so now it's bigger. Okay? Whenever the image ends up on the front side of the mirror, where the object is, the image is always going to be real. All right, and I'll come back and say that again in a few minutes, but it's time to go, oops, which way am I moving this, to case 4. And so case 4, we had object beyond C, object at C, object between C and F, so we keep moving the object in, so now the object's going to be at F. So object at F. And it's a shame that we're not together, because usually the diagrams drive people crazy, and images end up being slanted and all that kind of stuff. And usually I end up copying people take pictures of my diagrams on the board. So at some point when you can do that. So here's my object, it's at F. Now this time anything going in through F is going to be impossible. So we can't use the ray going in through F coming out parallel. Okay? So, but we can use the ray going in through C, going back through C. Okay, so with purple from the top, in through C, back through C. And then the other one you can use is in parallel to the principal axis and out through F. So with the same color from the top, in parallel to the principal axis, out through F. So they should look like that. Exactly the same two rays from the bottom. The bottom one's always harder for me to draw in through C. It's the angle, I guess. Okay, so in through C. Whoops, missed the object. I'll just make it longer in a minute. So it goes in through C, it comes back through C. See, the object's really down here. And then in parallel to the principal axis and out through F. Oops, sorry, that one didn't go over to F very well. Okay, now hopefully your rays look something like this. Look at my purple ones. They're better than my orange ones. They are not going to cross here. No matter if I extend them back or forward, they're parallel to each other. What that means is there is no image. So when the object is at F, there is no image formed. I have a really cool curved mirror at school that we will play with, I promise, and you'll see the spot where the image disappears, and it's really neat. Okay, so no image. Last case, case number 5. We're going to put our object between F and the mirror. between F and mirror. Okay, so my object is in here. With the purple from the top, I'd probably go in through C again. Hit the top of the object and come back out through C. Whoops. It's supposed to go like that. Okay, and then I'd probably go in parallel to the principal axis again. And then it's going to come out through F. Okay, and for the bottom, in parallel to the principal axis, sorry, out through F, hoping to hit F. And if you want in through F, easier said than done at this angle, in through F, out parallel to the principal axis. Now, let me turn this back around. You might, oh, that's definitely not parallel when I turn it back around. But that is. Okay, so you might be saying, okay, wait, I don't see where they're crossing. They aren't, but they also are not parallel this time. So there is going to be an image formed. You just have to follow it back to find it. So if we follow these back, because they're actually diverging, you will get an image form back here. And if you follow the reflected rays back, so this one, oops, and if that was only parallel, and this one. Now, oh, I followed that one with the wrong color. Shoot, this is orange. And orange. And the light from the window is driving me nuts because my blinds are. Okay. All right, so where the orange cross, that's going to be the feet. Where the purple cross, that's going to be the head. Here is my image. Look at it. It's right side up. If it's right side up, that means it's virtual. It's erect, right side up. It's larger, and it's behind the mirror. Okay, so the front side, where the object is real, and the back side is virtual. When we're doing math, which we're going to be doing fairly soon, whenever you get the distance for the object, the image to be negative, it means it's a virtual image and it's in behind here. Okay, but I'm jumping ahead of myself just a little. I have one more here, and it's the cases for a diverging mirror. So if you have a spot, I can come back to it, but if you have a spot, draw it down there, because then we'll have 6 really pretty pictures all in a row. Okay? So we'll come back to that. I'm just going to set those aside and come back to a different sheet and a darker pen. So there are equations that go with this. Okay, so let me just sketch one quickly so I don't ruin one of the good diagrams. So let's put C here and F here. And here's my object. Oops, purple. Going in parallel to the principal axis, out through F, going in through C, out through C. I'm cheating, and I'm going to say, okay, my object's going to be here. Okay, and I didn't do, or my image is going to be here. Okay, so I didn't do the rest of the rays because I don't want to run out of video time again. So this is the object, and this is the image. Okay? We already saw in these cases that the height of the object, the height of the image, is dependent upon where the object and the image are. The height of the object is set, but the height of the image changes depending on the location of the object and the image. So we have 4 variables, 5 variables, I guess, really. We have F, which is the focal length. We have